Hello all, and today I just wanted to do a short video to give some examples of graphs using the cool graph contest and to just explain the rules of the contest in a little bit more detail, and also to go over how to use the graphing tools on Desmos.com, because a lot of you might be unfamiliar with those tools. So to start off, this is our project for the term. So everyone's going to enter. It's going to count as a 40-point project, and that's going to go in the test, quizzes, assessments project category. So it'll be a decent chunk of your grade for term 3. So just some details here. It's due on Friday, February 27th by 1:55. Not everybody is going to have class on Friday. So we're encouraging you to turn it in early so we can check it over and make sure everything's in order. And this is very important because there's two portions here. You're going to be submitting a paper copy and an electronic copy, so all those copies have to be in on time. It's a very stiff penalty, 5 points late per day. That's a really stiff penalty. So if you handed it in on Monday, March 2nd, that'd be minus 15 points. Since it would be 3 days late at that point. So very stiff penalty for turning it in late. So definitely turn it in early, get it checked over early is our advice. So you're going to submit one polar graph and one parametric graph. And with each of these graphs, you can use up to 3 equations. So you can use 1 equation, that's fine. 2 equations is fine. 3 equations is fine. You cannot use more than 3. And you have to use Desmos.com to create your graphs, and you must hide your axes and grid lines. So let's look at the paper copy format. Like, what are you turning in hard copy wise? So you're going to turn in one graph in polar. That's going to be one piece of paper, and one graph, one parametric graph. That's going to be another piece of paper. So you're turning in 2 pieces of paper. The only thing that's going on the front is the graph and an appropriate title. And then the only thing that's going on the back is your name, and then whether or not the graph is in polar or parametric. You have to give a printed copy of the graph if you want to handwrite, the title and your name, and whether it's polar or parametric. That's okay. So let's look at an example of what my final paper copy would look like. Let me pull it up. Here we go. So my graph is titled "The Eye of Sauron." And there is my graph. I did this using one parametric equation. Produced this awesome looking graph, and that's pretty cool. Looks like Sauron's eye from Lord of the Rings. This has to be in black and white. The reason being is that the winning graphs get printed on t-shirts and sweatshirts for the math department. They're sort of the shirts that we get every year, and you'll see a lot of us wearing on Casual Friday. And we can only print in like one color, so just to make this all fair, and not everyone has a colored printer, just everyone has to do their graph in black and white. So the only thing that's on the front page here is the title, Eye of Sauron, and the graph. And then on the back, I've got my name, and that it's a parametric graph, so I would print this out double-sided and be good to go. If I didn't have a printer that could print double-sided, that's fine. I would just print out, the title and the graph on the front, and then on the back I would just handwrite my name and that this was the parametric graph. So if we look really quickly at the rubric, we'll see, so for the parametric graph, the printed copy, on the front you've got your graph in black and white and the title. On the back you put your name and the mode. I've got a separate page for my polar entry, and the axes and the grid lines were hidden. So notice if I just click back on my cool looking graph here, my Eye of Sauron graph, notice that the axes and the grid lines are all hidden, so I just see the cool picture. So you might be wondering things like, why is your name going on the back? Well, because we're going to vote, like all the classes in my room are going to vote on what the coolest graphs are. So we don't want this to be biased on, you're voting for your friend's graph. We want it to be like you're voting for what graph you think, the graphs that you think look really cool. So all the names have to be on the back. Great. So now let's look at what you're going to do for the electronic copy. Like, how are you actually going to make these graphs in Desmos. And I picked a parametric example here because parametric's a little bit trickier in Desmos. So you're going to make the graph in Desmos. You're going to log in using your school Google account, and then you're going to email it to us all right through Desmos. So let's check out to see how that is done. So here is Desmos.com. I logged in right here. I don't want to lose my graph here. Sure, let's do it. Let's sign in. See, I can sign in with my Google account or sign in with Desmos. Pick your Google account. Make sure it's your school Google account. It'll sign you in. It should say your name right there. Great, you're in. Then, how do you graph in Parametric in Desmos? So the way that this works is that to graph in Parametric, I have to type in my equation sort of as a point. So right here, this 1.1 raised to the t times sine of pi over 4t, that's my equation for x. And then this 1.01 to the t times the cosine of pi over 4t, that's my equation for y. So there's my x of t equation, like x equals that right there, and then y equals that. So the way Desmos wants you to type this in is that it wants you to type in x of t comma y of t sort of like as a point. That's the notation that Desmos uses for parametric. And then notice Desmos realizes this is in parametric, and look what it does right underneath. It puts the domain for my parameter, so I can play around with what I want my domain for my parameter to be and mess around with the picture. Great. Now, this is a little bit tricky. Notice that it's in black and white right now. If I click this button, this just sort of toggles the graph off and on. But if you hold down on the button, see, then it allows you to change between all the different colors. So just make sure you're picking black, so then when you submit it electronically, it's black. When you print it out, it's black and white. You're good to go. So when you hit the wrench, this is where you can play around with all your different window options in the grid and whatnot. So let me just turn everything on so we can see it. So here's how everything looks sort of with the grid in here. So I can pick whatever window I want, or if I just want to sort of do this manually, like without like picking numbers, you can like zoom in and scroll around, zoom in and zoom out really easily, and it'll change the window on the fly. So however you want to configure this is totally up to you, and then you can just go into the wrench, click the wrench here, and then you can see what your X window is and what your Y window is. And remember, your window for the parameter is over here, and I could toggle this, like if I wanted to have this like the polar grid there, I could click on that. You know, the angles, radians, and degrees I can toggle right here. So I definitely want to keep this in radians here. And then when I get ready to send this, I'm going to click off the grid, click off the axes here. I'm going to write down, you know, my X window, my Y window, my window for T, and then boom, when I'm ready to send this, right, you can go share graph, email, and then make sure your name is right there. Then you're going to type in your teacher's email. So if I'm your teacher, it's going to be cstrader@framingham.k12.ma.us. If my wife is your teacher, it'll be kstrader@framingham.k12.ma.us. So make sure your name goes here. And then in the message, this is where you need to put all of the details about your graph. So I think I have these, I typed these out. Here we go, electronic copy format. So the following information must be included in the message portion of your email. So we need the title, the class period that you're in, whether this is the polar or the parametric graph. Are you in degree or radian mode, your X window or your Y window, and then if it's the polar graph, your theta window, if the parametric graph, your parameter window. Great, so I think I typed all that stuff down right there. Boom. So I can copy that back over into my submission. So if I scroll up here, I've got Eye of Sauron as the title. Let's say I was in A period, I put down A period. This is my parametric graph. I'm in radian mode, and then I typed in negative 8.447 is less than x is less than 8.553. That was my X window. Then I also typed in my Y window and my parameter window right there. I've got my name here, who I'm sending this to. I hit send, and it's good to go. Now what this will look like when I get this email, look at how organized this is. It'll say your name. It'll be like, oh, so-and-so shared a graph with me. Okay, great. So I immediately know who it's from. And then right here, look at this. I get all of the pertinent information about your graph right here in that message box. That it's titled I have SAR on here, that this person was in A period, it's their parametric graph, they did it in radian mode, all of their windows. I mean, this is everything. And then check this out. When I click on the picture here, it redirects me right to Desmos. And then look at this. I can see, oh, I forgot to mention that. You click those arrows and you can hide the equations. I can see what equations you used. Boom. All set. So it's going to make it really efficient and easy for us to grade when you follow all of the directions. So let me just pop back over to the rubric here and just look at all of the things that when you submit your electronic copy, make sure you're emailing it using the share feature on Desmos, that you only use a maximum of 3 equations. For I have SAR on, I just use 1. I just had one parametric equation. And then make sure in the message you've got that title, your class period, whether the graph is polar or parametric, whether you're in degree or radian mode, your x window, your y window, your parameter window. And I had all of that, so I get all those 6 points. Boom. Email it through Desmos, you get those 6 points. Boom. And then, yeah, that's it. So it's 8 points for the physical copies, and you've got the 12 points for the electronic copy, making that 20, and then the entire project is out of 40 points because you get 20 points for your parametric graph and 20 points in total for your polar graph. So I just wanted to give you the one example, the parametric, because that's the one that the notation's a little bit more confusing in Desmos. If I wanted to just do an example here really quick, in polar this is easy. Like if I just typed in r equals 2 sine of 2 theta, boom, like Desmos would know that it's in polar, and then boom, it would graph in polar. Now that should be a flower graph, but it looks really weird because my window is weird. I mean, if I just hit square grid there, boom, I would get like a flower-looking graph. I mean, that's a pretty lame polar graph. I would have to change that to black and white. But I mean, that's just an example. When you're graphing in polar, it's pretty easy. For theta, though, you can either spell out theta, T-H-E-T-A, or you can, I think if you go to ABC, yeah, theta's like on the keyboard down there to bring up. So polar is easy. You just literally type in the equation like you think you would. Parametric, you have to type in sort of like as a point form, if you will, with your x equation, comma, your y equation. Great, so that was just a really quick rundown of everything that you're going to need for the project. So, I mean, you're going to be getting a copy of this, all of the rules and requirements. You're going to be getting the rubric. I just wanted to sort of go over some of the finer details of Desmos, but we're going to be working on this for a day in class, so you can ask any pressing questions then. And then, again, make sure you get this done and submit it early, and we can point out any glaring issues that we see when you submit it that you can change. If you sort of wait until the last second, we're not going to be able to look at it in advance. Then when we grade it, your grade sort of it is what it is. So you definitely want to get a good score on this. It'll be a good boost for term 3. It should be an easy 100, just following the directions through, and then we're going to have a lot of fun with this because people are going to come up with some awesome graphs, and we usually have a good time with the voting and checking out what everyone has come up with. It's a really good time. So I know we're all going to have fun with this. Good luck and have fun.